So we're going to go through differential equations. What we want to look at specifically in this tutorial is how we utilize the integrating factor to solve a given differential equation. So before we even continue, what do we need to know when it comes to us determining the integrating factor? Okay, so what it is that if you wish to solve an ODE, an ordinary differential equation, um, to find out how the variable of y depends on x. Okay, so you find that if the equation is first order, okay, if it's the first order, meaning the higher derivative involves the first derivative. So the higher derivative that you have, okay, let me say higher. Let me just say higher derivative that you have involves the first derivative there. So that's one thing that we have to keep in mind. Okay, so now the thing is that it is also like if what you have is also a linear equation, then this means that each term can involve y either as a derivative such as maybe dy dx, or through a single factor of y, just like that. Okay, so now that linear first order ODE that you have can be rearranged to give the following standard form. So it's like when you're given an ODE, we can rearrange it. If what we have said here has made a lot of sense, we can rearrange it and put it in the form dy dx plus px pxy is equals to qx, like that. Okay, so here our p and x, I mean pq, is it pq, p of x as well as q of x. These are functions of x. These two are functions of x, and in some cases they can be constants. Okay, so we should not always expect that they should be like some functions of x. It can be a 1, it can be a 2, it can be constants. Okay, those two can be constants. Okay, so you can say a linear first ODE can be solved using the integrating factor method, which is what we are talking about right here. So so first of all, what you have to do is that we have to identify what our integrating factor is. When you've been given your, or when you have your ordinary differential equation, you have to write it in that form. Okay, then you have to determine what your integrating factor is. Okay, so I'm going to indicate the integrating factor by this if, like that, integrating factor, which is going to be equals to e to the power integral of px dx, like that. Okay, this is how we are going to be determining what our integrating factor, meaning it's important that we understand how to put an ODE in that form, because it will help us to know where we have our p of x, and where we have our q of x there. Okay, so one thing that this is going to help us is that when we have determined what our integrating factor is, to come up with the equation that you're looking for. Okay, to come up with the equation that you're looking for, you're just going to say your y will be equals to the integral of the integrating factor multiplied by what? Multiplied by q of x dx. So after you have integrated here, what should follow is that we need to multiply our y, which is this one, by what? By the integrating factor. Okay, I need to multiply that by the what? By the integrating factor. So now let's try to look at some few examples so that at least we try to make sense out of what we are saying right now. And it's very important that we really know how to go about this, because let's say you are trying to determine whether an ODE that you're given is exact or not. If you find that it's not exact, you are able to use you're able to determine what your integrating factor is, and it will help you to make that differential equation that you had that was not exact, you make it exact. Okay, so now in the first example, let's say we are given dy dx plus y is equals to e to the x. What does this mean? What it means is that our p of x is equals to what? Is equals to 1. Remember we said it's not always that it's a function of x, sometimes it can be a constant. So I'm just picking the coefficient of y there, that's my p of x. Then what about my q of x? This is equals to what? My e of x. Okay, so now what I need to do is that to determine the integrating factor, we said integrating factor, it will be equals to e to the power the integral of p of x dx. So how is this now? It's e to the power integral of, what's our p of x? Is 1 dx. What do we get now? The integral of 1 with respect to x is equal to us, is equals to x, like that. So that's what our integrating factor is. It is e to the x. So now we can go ahead and determine what our equation is. We are going to say, okay, our y will be equals to the integral of the integrating factor multiplied by q of x dx. Okay, it's very important. That is, of course, there might be some way in which someone is able to write this, but this is the easiest method that I can use myself. I just write it in that way. Okay, so here my integrating factor I found that is e to the x multiplied by my q of x is also e to the x dx is equals to, so this is going to be e to the 2x dx. Okay, so integrating this, what you're going to get is that this will be e to the 2x divided by the derivative of what you have there, which is going to be what? Which is going to be a 2. You are differentiating this with respect to x, that is going to give you a 2. So this you're going to say is plus what? Plus c. But remember, we said to find the final equation, we have to multiply our y, okay, not everything, but just our y itself, just this y by what? By the integrating factor. So you're going to say it's integrating factor multiplied by y is equals to what? Is equals to what we have right here. But I have my integrating factor as e to the x. Okay, I'll say e to the x there. Okay, e to the x multiplied by y is equals to e to the 2x divided by 2 plus c. So now we can divide both sides by e to the x. That would be like I'm going to say wait a minute. So that would be like y will be equals to e to the 2x divided by 2e to the x plus c over e to the x. Okay, so how is this now going to be? You observe that here what you have is the same as you saying e to the 2x minus x divided by 2 plus plus c over e to the x. What is this going to be? This is just going to be e to the x divided by 2 plus plus c over e to the x, which happens to be what? The solution that we are looking for. Okay, so now that's how we go about that one. Let's try to look at another example. So now let's say we are given dy dx plus 1 over 3 y is equals to 1. So the emphasis that you are like one of the important things that you're supposed to keep in mind is that when you don't when you have been given like something in this form, okay, then maybe let's say there is something here or whatever, you're supposed to write it in the standard form that that I showed earlier. Okay, so looking at the way it is right now, everything is okay. I can go ahead and say, okay, my p of x is equals to 1 over 3, then my q of x is equals to 1, or let me just say my q is equals to 1. So in this case, my integrating factor will be equals to e to the power to the power of like the integral of p of x, which is 1 over 3. Okay, 1 over 3 dx there. How is that going to be? That will be e that will be e to the power 1 over 3 x, like that when we integrate. Okay, so now we can say now the equation y will be equals to y is going to be equals to the integrating factor multiplied by q of x, which is just a 1. So we are simply saying e to the power 1 over 3x dx. Okay, so when we integrate that, okay, when we integrate that, we are going to find that you're going to say it is e to the power 1 over 3x divided by the derivative of that, which is simply 1 over 3. But I won't do that. I will say I will just put the 3 there. Okay, then I will say plus what? plus c. Keep in mind, once again, multiply that by the what, by the integrating factor, so your y will be equals to, so I'll just divide this by what, by the integrating factor in short. So I'm going to say it's 3, I'm going to say 3 e to the power 1 over 3x divided by e to the power 1 over 3x plus c divided by e to the power 1 over 3x, like that. That just ends up to be 3 plus, I can say c multiplied by e to the negative 1 over 3x, or I can leave it on the denominator, is still okay. So that's what I get right there. Okay, let's try to look at another example. Okay, now let's say we have our dy dx to be minus y, okay, then is equals to what, is equals to sine x. So what does this mean? Our p of x is equals to negative 1, q of x is equals to sine x. Okay, I'm glad we have something that is a bit different now. So integrating factor without a doubt is going to be equals to e to the minus x, like that. We integrate negative 1, we get x, but we also use the negative, like that. So our equations are going to say y is equals to, let me say our solution. So y will be equals to the integral of the integrating factor multiplied by the what, multiplied by q of x, which is sine what, sine x dx. Okay, so now this is where we bring in or like we remind ourselves of integration by parts. So what it is here is that I can utilize what is called Liate. I believe now we are familiar with this. I'm going to pick my u to be equals to the trig function, which is simply sine x, because it comes first. So the exponential, it comes at the end, so meaning that to be my dv, which is simply equals to e to the minus x. So meaning my u prime will be equals to, or let me just write it as du will be equals to cos x dx. Okay, so meaning our v, we integrate that, that is going to give us minus e to the minus x there. Okay, so we can now say this is equals to u by v, we are going to get minus e to the minus x there. We have sine what, sine x minus, okay, we're going to say minus v by du, but I have a negative here. It's going to multiply out that negative. This is going to be positive. That'll be positive e to the minus x, okay, then cos what, cos x there dx. So you observe again to say here we can do we can use integration by parts for the second time. Okay, so now we can say our u is now equals to what, is now equals to cos x, then our dv is still what, e to the minus e to the power minus x. So meaning my du will be equals to minus sine of x dx. My v is still going to be minus e to the minus x there. So we can come and say our y is equals to minus e to the minus x there sine x, then I'm going to say plus open bracket u by v, I'm going to get minus e to the power minus x cos x there. Then I'm going to say, is it supposed to be minus? I'll say minus. So this will remain a minus because this one and this one are going to be a positive when you multiply them. So that will be the integral of e to the minus x there sine x dx. Okay, so now we have something that we're able to work with props. So now this is going to be e to the minus x, so minus e to the minus x there cos x, okay, that would be minus integral of e minus x there sine x dx. So keep in mind to say this part here is more like the integral that you are looking for. Okay, so what it is that it's more like you are saying you had your I is equals to everything here. Okay, I'll say this part here, I drop it here, then I'll say minus what, minus I again. Okay, So now how does this now become? So here we can now say our y, okay, our y, not really our y. This is going to be when you bring the I on the other side, like you're correcting the like terms. This is going to give you 2I is equals to minus e to the minus x there, sine x minus e to the minus x cos x. Okay, so we're going to say I will be equals to minus e to the minus x there, sine x minus, or I can do myself some justice here and say okay, I can just say open bracket, then I'll say plus cos x, like that. Still one and the same thing. That would be divide by 2 there. Okay, so now remember to say we need to multiply by this part, which is now which is in this case I'm going to indicate it as y. I'll multiply it by the integrating factor, then meaning I'm dividing everything by the integrating factor. That would be your y will be equals to, oh, by the way, we have a c here. So this is going to be when you divide everything by the integrating factor, okay, integrating by the integrating factor, which is what we have right here. You're just going to remain with minus sine x minus cos x divide by 2 plus what, c over my e to the minus x, of which if you want, you can not use a negative, you can just write e to the x like that, and that's what we have. Okay, so now let's try to look at another example. Let's say you have x dy dx plus y is equals to x. Should I really finish this one? It looks like it's the same thing that we are doing over and over again. Let me just write it in this form. So here, remember to say we're just supposed to have a dy dx here, not x dy dx. So I can multiply everything by 1 over 1 over x. That's going to be dy dx, then say plus y over x is equals to what, is equals to 1. So this is how it's going to be, and I believe you can pick your, you know, to say your p of x, your p of x is equal to 1 over what, 1 over x. Your q of x will be equals to 1. So you can continue from there. So try to work it out, then you can leave your, you can give us your, we can share with us your solution, your finding from, I mean, in the comment section. Okay, so now let's look at the last example. We say tan x dy dx plus y is equals to sec x. Okay, so now here once again I'm going to multiply by tan by 1 over tan x, which is just going to give me dy dx plus y over tan x. So this will be equals to I'm going to have, what am I going to have here? I'm going to have sec x divide by tan x. So we can simplify this part and say this is going to be equals to what? That will be equals to cosec x. Why am I saying so? Sec x is simply 1 over cos x divide by tan x, which I'm just going to multiply by the reciprocal of tan x, which is a cot. In that case, that is what, cos x over what, over sine x. That can go and that can go, and 1 divided by sine x is simply equals to that. Okay, so now what are we going to do from here? We have seen that our p of x will be equals to 1 over tan x. Then our q of x is simply equals to what, cosec x. So we can try to determine the integrating factor from here. Okay, so we're going to say the integrating factor if will be equals to e to the power of like the integral of p of x, which is simply 1 over tan x is simply cot x. So I'm looking for the integral of cot x dx, of which this is going to be e. If you go to the table of integrals, or you want to do it yourself, you get ln of sine x, like that. Okay, of which this is just simplified to what? Simplified to sine x, like that. Okay, so now you can say now y will be equals to the integrating factor, which is the integral of the integrating factor sine x multiplied um, by q of x, which is simply cosec x, which is just 1 over sine x. There we say dx. What are you going to get? You're going to get, like, you have your 1 dx. What you get is simply x there. Then once again, you just multiply your y by the integrating factor, so that will be your y. We have a c here. Y will be equals to um, x divide by sine x there, plus c divided by sine x. Okay, so or I can just write it as cosec x open bracket x plus what? Plus c, and that's what I have right there. So that's how you go about answering questions that involve you utilizing the integrating factor to find the solutions of a differential equation. Thank you very much for watching.